Okay, so in this PowerPoint, things are going to be a little bit nicer and easier. This is just a bit of an introduction to radioactivity, and then we'll go on to types of radiation and how we can use radiation and dangers and stuff afterwards. But just to give you an idea, as like we did with the atom itself, a bit of background about radiation now. One of the things that we'll do is with this, I'll pop a poll onto the Google Classroom, and I'd like you guys to vote for the words, or pick the words that you would associate with radiation out of interest, to see how you view radiation as a thing before we get started. So don't carry on any further with the PowerPoint or with the video, just stop there, do the poll, pick the words which out of the ones that we put there that you would associate with radiation before we go any further, and then we'll have a look as we get into the topic a little bit more about how you view radiation before we start. Now, radiation or nuclear radiation is are particles or waves, alpha, beta particles, gamma ray, which is electromagnetic radiation. It's a wave that's given out by radioactive substances, and these radioactive substances that are decaying, well, this decay is going on in the nucleus, so sometimes we call it the nuclear radiation. Now, we've got the atom, and we've seen already, with the protons, neutrons in the middle, electrons on the outside. So in a radioactive atom, or a sample of radioactive material, or radioactive isotope, because it's usually only certain isotopes of an element that are radioactive, this nucleus is unstable to a certain degree, and it will give out particles or waves to become a more stable atom, and this is called radioactive decay or radioactivity. And this is completely natural and spontaneous, which means we can't affect when it's going to happen. Spontaneous is random. We don't know exactly when it's going to happen. The only thing we can do is a little bit like betting on the horses or the football matches. The only thing we can do is calculate the probabilities of something decaying, giving out radiation, but we can't control when it actually happens. Now, radiation is all around us. There's no need to be afraid of it, because we are receiving radiation right now as you look at the computer. Where is it coming from? Well, it's invisible, which is one of the most disturbing things about it, but it is natural. Our body is used to living under a certain level of radiation in the natural environment, and then there are man-made sources of radiation which increases the amount of radiation that our body receives. But in order to see where this radiation is, one of the instruments we use is a Geiger-Müller tube. Müller and Geiger. Geiger was one of the students of our, oh my God, what's his name? Rutherford students studying radioactivity, who Rutherford came up with a nuclear model of the atom, and Geiger was one of his students. Now, this tube basically has some gas, has a very thin window to try not to block the radiation from coming into this tube. It's a metal tube on the outer part, which is attached to one side of a potential difference, a voltage supply, about 600 volts, and then a spike, a piece of wire, bare wire on the inside, and then the tube is filled with gas. So if any radiation, and we call this ionizing radiation, because alpha, beta, gamma ray radiation has got enough energy to knock electrons off atoms. So if this radiation enters the tube and knocks electrons off one of these atoms of gas that is inside the tube, that's going to become an ion. The ion is going to be attracted to one side. It's going to get attracted to the negative side of the potential difference, and the electrons are going to get attracted to the positive side. And when we get these, we receive these, we get a tiny little bit of current flowing through the gas. So that's how we detect ionizing radiation, by this tiny little bit of current that flows. So this detects and measures radiation, and it will measure how many ionizations it receives per second. So we get counts per second, number of ionizations per second. We can also use radioactive photographic film, because photographic film will change colour, it will develop when it gets struck by radiation, and that's how radiation was initially discovered more than 100 years ago, which is what we'll look at very quickly now. It's also what we use for radiation dose meters. People that work in nuclear power plants will carry a badge every day that will gradually change colour as they receive a dose of radiation. So once that has changed colour, they know that they need to go home or need to leave the area so they don't receive too much radiation. So what it is, we'll just reset this, start the story. It was Becquerel, a French scientist who was working with uranium salts, and he was studying how that they had on photographic paper, photographic plates, when he placed the salts on top of the plates, and he thought that leaving the uranium salt in the sun caused it to give out some kind of radiation and change the photographic plate, so he got an image of the uranium salt. And he thought it was the sun causing this, the energy from the sun going into salts and then coming back out again. But then one day, it was a cloudy day, so he gave up on his experiments and put everything away into a drawer. When he developed these plates on the cloudy day, he got a faint image of the uranium crystals, which he was very puzzled about because there was no sunlight getting to them. So he worked out that it was the actual uranium salts that were giving out some kind of radiation by themselves. So the uranium was emitting some kind of radiation without getting energy from the sun, and he discovered that it wasn't X-rays that had recently been discovered, it was some other kind of radiation. Now we know that it's gamma radiation from the uranium nuclei that are decaying. So then it was Marie Curie, Polish scientist, and her husband who worked with uranium ore and found two new radioactive elements, polonium, they're named after Poland, and radium, which is so radioactive that it actually gives out heat and it glows in the dark as well. We used to use it for making watches that glowed in the dark but were radioactive. And Becquerel and Curie won the Nobel Prize for physics for discovering radioactivity. And then later on in 1911, Marie Curie received the Nobel Prize for chemistry for discovering polonium and radium, and was the first person to ever receive 2 Nobel Prizes. And also, very strange in those days, a female scientist. She died in 1934 from some strange blood condition, probably cancer caused by her work with radiation. To give you an idea, polonium was used to assassinate a Russian spy in London about 10 years ago. And it was micrograms of polonium that were put into his tea. And that was enough to kill him within a few days. So pretty sure that working with polonium is what caused Marie Curie's death, unfortunately. But we found that out later on, that gamma ray radiation and radiation causes cancer. So she had no idea of what she was working with. We didn't know until later. Okay, so that's a little bit of history of radioactivity.